Hello?
Hello.
Hello, Mr. Harry, Mr. Ryan, are you right?
Yeah.
So, what did we talk about last lessons? Remember?
About three-digit number, find the three-digit number, even numbers
Yes.
from a list.
So, we given an array of digits, single digit, and there could be a duplicate, right? It could be duplicate.
Three.
Yeah, something like that. And we want to find all the three-digit
Numbers.
numbers. Even number. And no leading zeros, okay? So we can't have like 0, 1, 2. This is not a good number, right? But we could have 1, 2, 0, 2, 1, 0. And since they are 2, 2, so we only keep one copy of that, which is 2, 1, 0, okay? So we talk about the brute force. Brute force, yeah. How do we brute force? We talk about permutation, right?
Try to check every three-digit number.
Yeah, there are two ways. So
And then start from like 100 to 999 and check if it can be. Skip every odd number and check if it can be the even numbers and if it can be made from the array.
excellent. Yes. So there are two ways of brute force. One way is because it's a three-digit, right? So brute force, try every even number from 100 to 998. Yeah. Skip 2. So for I in range 100 here 999, step 2. And once we have this number, for example 102, we come back to check if 102 can be made from the given digit. And this is more efficient because there are limited number of the three-digit numbers, and we can just do this in constant time. The loop. The other way of brute force is using the permutation because we are permutating three digits out of these n digit. Okay.
Mm-hmm.
We can brute force these the whole number, or we can brute force each single digit, right? So let's say A, B, C. This is the three-digit number, so we can do this for A in range no leading zero, right? Because it's no leading zero, so we start with 1 up to 10, right? No leading zero. For B in range, the second digit, it could be any from 0 to 9, right? For C in range, the third number, okay, so what's the third number? The third number has to be even digit, right? Because it has to be even number. So the third number would be from 0 to 10, step 2, right? So 0, 2, 4, 6, 8. This is what it means. And then once we have this ABC, we check if counter ABC is smaller than this counter, then we don't need to check leading zero, right? Because A cannot be 0. We don't need to check for even numbers, right? Because C, we step 2, right? And then after that, then we can push this to the answer, which is A times 100. A times 100 plus B times 10 plus C. Okay, do we need to solve this using this kind of for loop? Do we need to solve these numbers?
Not really, because A is 1 to 10.
Yeah, look at what the numbers generated. So A from the smallest to the biggest, B from the smallest to the biggest, C from the smallest to the biggest, right? So this number generated is also from the smallest to the biggest. It's the same thing like this for loop, from 100 to 998, step 2. Right? Okay, brute force, permutation, Pn3. Yeah, Pn3.
IPM3.
Picking 3 out of n with the sequence. Cn3 is picking 3 out of n with the order does not matter. So Pn3 is actually Cn3 times the P33. Okay, this is the full permutation. We're using the depth first search last lesson, right? Depth first search, and we can use the breadth first search. But because we are only picking 3, alright? Well, because we're only picking 3, so we can also do this. Not looping over the numbers, we're looping over the index if there are n. So we can say for the first index is range n, right? The second index for j in range n. For the third index is also from range 0 to range n. But we have to check if I equal j, then we continue. We don't want a duplicate index, right? Because each index can only be picked once. If I equal k or j equal k, then we continue. we ignore it, right? So, and once we have the IJK, we can test if this number is an even number without the leading zeros. And then if it is, then we push it back to the result. And then, but after this, we need to sort it, right? Because we are just picking the index. Okay, so depth search, we use recursion, and then once we pick it, we pick this number, we follow it, and we need to give it back, right? And about the breadth search, how do we implement the breadth search? Anybody? Breadth search.
Oh yeah, Q.
Q, okay? No, depth search, okay? Define depth search.
Recursion.
Recursion, yeah. If n is bigger than equal to 99, we need to check if n is an even number, and if it's an even number, we push this answer append. Answer could be is a set. Okay, answer is a set. So answer dot add n and then return. And then we need to go through each digit for I in range 10. Right? And then if this frequency, if frequency I is bigger than 0, then we follow it. Right? We have enough digit of I, we follow it. I minus equals 1, and then depth search. So current number is n, so n times 10 plus I. Right? After recursion, we need to give it back. Frequency I plus equal 1. And depth search at the beginning, we start with 0 and then return sorted answer. Right? Okay, so this is the depth search. At the beginning, the frequency, it needs to be computed using this counter digit. This is depth search. Let's do this breadth search. Breadth search, we said we use the Q. First in, first out, right?
DQ.
First in, first out. So we push the kit. Every time we DQ, we take one from the left hand side, pushes the kit back to the Q, okay? So the breadth search, level by level. Depth search as deep as we can. Okay? Which method guarantees that the first solution we get is the optimum if we are looking for the shortest?
Breadth search.
Breadth search, okay? But in this case, it doesn't matter because we are finding all the 3 digits, right? We're actually finding all the 3 digits even numbers, so it doesn't matter depth search or breadth search. We have to perform the entire search using the depth search or breadth search, just different order, okay? At the beginning, answer equals set. Why are we using the set? Anybody?
Because we need to store numbers in. So it
We don't want to add
remembers-
duplicates, yeah? Okay? Set the unique,
So
only
it
store.
remembers the numbers.
That's right, unique numbers. So it doesn't store the duplicate. Right? For example, if its answer is a list, it's a list, this is a list, right? Answer dot append 1. Answer dot append 1. Another one, answer dot append 1. Right? You store 3 elements. But answer, if it's a set, answer dot append 1. Okay. Using curly brace, the set, okay? Answer dot append 1. Nothing change because 1 is already in the set. Nothing changed. Okay, this is the major difference. Okay. Q, DQ, double NQ, we can do this push and pop on both sides. DQ. We need to store the current number and the digit, right? We need to store the current number and the digit. So the current number is 0. The digit is counter ARR. Okay. So this is the tuple, and then wire Q. So N F equal Q dot pop left. Taking from the left hand side, Q dot pop left. N, this is the current number. F is the remaining digit. Okay? So here, if N is bigger or equal, if bigger than 99, okay? Actually, okay, so it's bigger than 99, not equal, okay? 3 digit bigger than 99, or bigger or equal than 100. Well, if N is odd number, then answer dot add n, return here. Otherwise, we need to go through each digit for I in range 10. So now we need to make a copy of the counter, right? Counter is the object. So counter, let's say C equals copy dot deep copy. Copy, this is a package, deep copy. What's the difference between deep copy and shallow copy?
Deep copy is kind of deep, is it? I think you call it something like alien. Like A equals B, B equals A.
Deep copy. What's deep? Deep is clone. Okay. A equals 1, 2, 3. Okay. If I say B equals A, this is not deep copy because if I say B0, I want to change it to 4. So what happened here? B would be equal the first element to 4, right? 4, 2, 3. A is also changed to 4, 2, 3 because B equals A. B is just an alias pointing to the same.
Yeah, alien.
Yeah, alias. That's called shadow copy. This is shadow copy. But if B equals copy dot deep copy A, then B and A is a separate. It's like Eric. I want to make a clone of Eric and another separate Eric is here. Okay.
Eric the second.
Yeah, I touch this Eric. Doesn't mean I touch the other Eric, right? This is a separate copy. Copy dot decopy. We can also do this syntax. B equals A, and then put the what's this?
That's a colon. That's a colon.
Oh, colon, not semicolon. Yeah.
Yeah, semicolon.
Had that little comma instead of the bottom dot.
Okay. So this is 2 dots. You know, this is comprehension. It also means a deep copy. Okay. And we copy this, and then if Ci is bigger than 0, right? If we still have enough digit of I, then we can make a copy and then push it back to the queue. Q dot append. So what's the next? Next is current digit is n, right? So n times 10 plus I, and then deep copy, which is C here. Okay, and then we need to sort it, right? Again, we need to sort the answer. Here, we don't need to give it back. Okay, so if Ci bigger than, we copy it, then we Ci minus equals 1, right? We need to decrement because we're using one more digit of I, but we don't need to give it back because we're making a deep copy. Okay, it's different than depth search because this frequency is kind of global. Every recursion call is modifying this counter. So once we decrement, we borrow the digit I, we need to give it back. Does it make sense? Mm-hmm. Here we don't because we make a deep copy. We push it to the queue. The node in the queue has a number and a counter. So it's a different counter, right? Different counter. So it doesn't matter. We don't need to change it back. Okay. So by looking at this both approach, the depth search, breadth search, the same time complexity in this case because we need to find all the 3 digit even number. We are actually proof of using different traversal order. But the depth search space usage is less than the breadth search, right? Because breadth search we need to store all the nodes in the queue, right? For depth search, we don't. Make sense? Last time we talked about iterative dependent search and the breadth search, depth search. There's a difference in the space usage, okay?
About finding even 3-digit numbers from an array or using depth of search.
This is depth search. We are not talking about depth search. What's this?
Deep
What's this approach?
breadth of search.
Breadth search. Okay, so this is not new today. This is what we talked about last time, okay? Just different ways of solving this problem, okay? Can you?
Deep copy.
I learned about the 3-digit even number thing. So we learned breadth search and the deep copy. We use the deep copy so we don't have to borrow it because in something like shallow copy, like for shallow copy, it does it to both, kind of like it's like a mirror. So like what you do to one, it does to the other. So it's kind of like a mirror. And so so you do something to B, you have to do it to A. So we don't want it to do A, so we put A back so it didn't. And so that's why you decopy so we don't have to borrow it.
Okay, one last question. What do we store in the nodes of the breadth search? In the queue, it's a tuple. So what's 0? What's counter? What's this? What's the first number? What's this? What's F? Q dot top left. Look, we're taking the node from the queue. So what do we store in the node?
The numbers 1 to 10.
The current number,
Values.
N is the value is current number. We are brute forcing the 3 digit, right? This is current number. F is the remaining digit we can put on the right hand side of the current number. Now you get it, right? So that's why we check if Ci bigger than 0. We still have remaining digit of I, then we can put it on the right hand side. N times 10 plus I. Right? For example, if N equals 12, 12 times 10 is 120, plus 3 is 123. And then remaining digit is C. We made a deep copy of the current remaining digit and we decremented it by 1. Okay? Okay, that's it. Bye-bye.
Bye.
Bye.